introductional, and the entry level is so that I presume you have at least minimum understanding about what exactly Docker is. And a couple words first about myself. I am a senior software developer at Folkefinans. We're in financing business, loan, credit cards, that kind of stuff. We operate on multiple markets in multiple countries, mostly Scandinavian countries. And we are represented in Estonia as well with brands Moneti and Folkia, both loans and credit cards. And as we run a number of web applications in production for different products in different countries, so we decided that switching to container-based architecture could be a really good decision for us, as we can reduce maintenance cost and also unify deployment pipeline for multiple for all of our projects. I'm not gonna go in details about what exactly benefits do you get from container-based architecture. You can find lots of reads about it on internet, but we'll do, however, focus on how exactly do you roll out Docker containers on AWS services. What we have achieved architecture-wise looks like following. When a user requests one of our sites' hostname, it gets forwarded to Amazon's Elastic Load Balancer, and then Load Balancer forwards the request to a running container instance, and container instance runs inside of Amazon EC2 instance, and they run inside of a cluster. I forgot to say that if you will have any questions, ask right away so they don't get forgotten. That's pretty much it. Fairly simple from this point of view. And before we go proceed any further, I'd like to give some explanation on glossary, and that's actually AWS specific. First, a task. You can think of a task as an executed command on a Docker container. It can be, for example, running web server, or running worker or scheduler, or can be also a command that can exit with some code and that's it, not be running further, like running a migration or setting up database, bootstrapping data, that kind of stuff too. Pre-compiling assets, for example, as well. And task is described by task definition. It's a configuration that can be made in JSON or via AWS user interface, and it describes where do you pull the image for this container, like how much of resources do you allocate. Then you can specify also tags for the image. Then you provide a command, set up environment variables, everything basically that you need to describe, that you need in order to describe your your container instance. And task definitions are also revisioned. So whenever you create like a new one, then like it creates a new revision of it. Then service make sure that specific given number of tasks are running described by given revision of task definition and available behind given load balancer. And if something goes wrong, your running instance dies, for example, then it spins up a new one. Or if, for example, load on your for example, if your memory or CPU consumption grows, then and if it can spin up a new task temporarily, then it does so. Now let's proceed directly to how exactly do you set it up your AWS cloud. First, you need to set up a cluster. Cluster is a set of EC2 instances that are available to each other, and in cluster you can define how much of running instances do you need, what is the minimum and maximum amount of running instances at a time, so it can adjust them. And there you can have your instances to be available in different availability zones. One can be, for example, in Ireland, the other in China, and etc. And under cluster, you can see all your services available as long as tasks, and you can also see different kind of performance metrics about this cluster. Then, of course, you need to build your images somewhere. We prefer hosted service in order to do this. Default choice would be probably Docker Hub. We unfortunately didn't really like Docker Hub. Not to say we like this one a lot, but it just was like second good enough choice, and we're kind of bear with it. But this GUI service we use for building our Docker images is, to be honest, far away from perfect, and we keep looking on other more decent solutions maybe. And here you can also tag your images, and so you can specify tags in task definitions. So task definition knows what image to pull. And then once you have your cluster set up and images available on the internet, then you can describe task definition. And as I said, here you can tell it how much. I don't know if it's even like visible from back seats or not. You can tell it how much CPU units and memory do you allocate to it, whether it's essential or not. And essential means that it is like a primary running task. For example, if your service requires a number of tasks to be running, like for example a web server and a worker to do background jobs, then there is no point to execute worker if a web server didn't start, right? So in this sense, web server will be an essential task. Then you pass on a command that executes where you need to be executed. In our case, we ship Ruby on Rails application, so we run Puma server with some configuration. And then you map ports, host port and container port, so requests can be passed on till the very running container somewhere deep inside Amazon data centers. That's pretty much it about task definition. And before you go any further, you need to set up your load balancer. And for load balancer, you can also specify ports and specify allowed availability zones, as well as you configure certificates in case if you require HTTPS protocol and that kind of stuff. Who have ever worked with AWS services and in load balancer, with load balancers in particular? So probably I should not be stopping much on this one. Then when these preconditions are fulfilled, you can actually proceed with describing service. For service, you define, you specify load balancer to use, then you specify task definition and revision of it, and for service you also define desired count of instances and running count of instances. Say that the service also does one really cool thing. So, for example, you have your application running two instances of it, and then you want to roll out an update, and you create a new revision of task definition for the updated version. Then you update service, and you just change the revision of task definition, and then you save the update, and then it starts to spin up. It pulls the image, starts to spin up at first one instance of a new type of task. Ensure it's successfully up, have reached its steady state. Then it starts draining connection to one of old revision tasks. When it's done, it spins up another new revision task. And when this one is also up and running, it starts draining connection to one remaining old one. And this way you achieve blue-green deployment, and your application constantly available. And that's normally a good thing. And with this setup, you basically get your this is basically minimum setup that you need to do in order to get your Docker containers running in AWS. Now we have implemented this one fairly recently. We only have it in production maybe a couple of weeks tops. And alongside with a number of benefits that we were like expecting and we also got, we have noticed certain drawbacks as well, and I would like to cover them as well. So if they're like showstopper for you, so you don't fall back with this idea. First of all is deployment pipeline. The problem about it is that it kind of sucks. We used to run continuous delivery with CodeShip that built our stuff and executed deployment script, whether it was Heroku or deployment our own server with Capistrano. But here you cannot really do this, because after you run your normal build, like running test suite and sanity checks and that kind of stuff in CodeShip, but you built your Docker image in different environment, in Way, for example, like in our case. And once normally CodeShip build finishes like much faster. Sorry, and then it doesn't know when container build or Docker image build is ready, and it cannot be notified. And same with Quay build. Once it's done, then it can do nothing about the image. It can just publish it on the internet. That's it. There are solutions, however, to this problem that allow you to achieve continuous delivery back again. First of all, there are described solutions on the internet how you do it with Jenkins. So you make Jenkins build your builds and run your test suites. So then you have control over these events. And then after everything is ready and green, you can execute deployment script, like over AWS command line interface, create new revision, update service, so it spins up a new stuff. But we are not currently there yet. We just, to be honest, didn't have time to get there. We are experimenting with different opportunities and look forward to make our deployment better. I know that there are also some hosted services that provide you such opportunity, but we didn't manage to try any of those. I know that there's one called Shippable, then was Wrecker or some kind of something, and there's also again AWS. They like have plans to roll out their own container build service, and also CodeShip is working on it too. So there probably is going to be a solution for this one pretty soon. Then deployment notifications, also we haven't yet figured out how exactly to do this. For example, in case you want your monitoring system, New Relic probably, to get notification whenever deployment is done and what exactly has been rolled out, like changelog, then currently we don't have a way to do this. I believe once we have our deployment automated over command line interface, then we can easily update New Relic server with the webhook, and then it won't be it won't be a problem at all. And also emergency rollbacks. We kind of figured it out, but it can get a bit tricky. Imagine a situation when you deliver some environment-specific feature say you want to switch the way you serve assets in production to CDN way, like you want to serve your assets from Amazon CloudFront or other content delivery network. And as it's tied up with the host names and maybe there are other reasons that don't allow you to test it in staging or other test environment, and you have to do it in production, or it's just something that got for any reason in production and it broke entirely production, something got wrong, and you need to roll back fairly quick, like under a minute. Then applying a hotfix and pushing to source control, running checks again, building a new Docker image can take ages. I mean, yes?
When you're talking about emergency rollback, and you just go back to the previous Docker image that you...
Yeah, but if it's you can go back to previous task definition, but this doesn't necessarily. This is not necessarily same thing, because for example, you deploy your production from master branch and you tag your master branch images with master tag. Then once you update master, it also like moves master tag from previous master to new one, and that's it. You need to apply hotfix, and this previous master gets lost. And so solution to this is introducing some kind of intermediate tag like latest table, or call it whatever you want. But the bottom line of this approach is that once you have rolled out a new version of your application and you have verified that it actually does run stable in production, you just move manually this stable tag to it. And then in case you deploy something that smells to production, you can quickly revert to previous revision that has tagged with latest table. And this way, yes, this exactly idea reverting to previous, not revision, but also image, does work. This is pretty much it about what I wanted to share with you. Maybe you have any questions to ask.
Do you know if in Amazon ECS service you can use like a custom load balancer, like a hub proxy, instead of Amazon like built-in elastic load balancer, which is like not the best tool in the world?
I don't know for sure, fortunately.
Services are tied to Amazon elastic balancer, so if you want to use built-in services, then they usually tied to like only Amazon balancer.
Okay.
Yes?
In Docker, you have read only the file system. Do you often slim down your Docker? Like when I was playing, then it went really huge quite quickly.
Like you mean image size or memory consumption?
Yeah,
or
image size.
Currently rollout, well, we do mostly Ruby on Rails, and we have images of size maybe 3 to tops 500 megs. That's not really an issue for us, so we never even like thought about whether it's a problem for us and do we want to solve it.
But when you release new things, you always put top of the to remove old versions from
AWS or from Quay.
From the Docker image. Like it stacks up with after a while. It's going quite big, no?
I don't even know. We actually didn't notice that our images have tendency to grow. Maybe that's specific to technology stack you use. But we never actually noticed this problem.
Sorry, I was late, but are you running only one processor per Docker, or you're multiplying with like cron and I don't know, SSR? And I know it's an anti-Docker, but personally, are you running?
We run our web applications in a single thread, but we run multiple instances of them behind a load balancer. And we run as many workers as we find necessary to run background jobs. We execute some chunks of business logics in background jobs.
But those are outside Docker.
No, they also run in Docker containers, but.
Okay.
Last question, anybody? Oh, okay, thank you. That was me.